Okay, so we've got two different classes which aren't related to each other, i.e. they're not using inheritance or polymorphism. They're two separate classes, one called student and one called course. Now, do they use each other? Yes, and let's talk about that. We've created three different objects, student 1, student 2, student 3, so we instantiated three different objects, three different instant variables, one called Alice, who's 20, Bob 22, and Eve 21. We're now going to give the course Computer Science these three students. Students can be accessed, so we can still have students, so think about a scenario, without being a part of a course. It could possibly happen. So the relationship would be aggregation. We're basically saying that student can exist outside of course. We can access the information outside of course. It would make sense that we could access the information outside of course. So it'll be an aggregation. That would be the relationship. Now we're going to change it slightly where we're going to also track the grades of each student. So Alice, Bob, and Eve. Let's see how we can do that. So we've got our class student, the same. We've got our class grade, which will give us our student information and the grade they've got. And then we've got class course. Notice the difference between class course here and class course here. In this, we just want to record the grade information of each student. Class grade will store the student and the grade they've got, so we'll still have that information, but the course will simply put like computer science, A star, B, C, or 50%, 30%, 20%. So let's actually have a look at this in action. This is saying that the student is exactly the same. Each student, student 1, is given a different percentage score. And then we're going to pass into course computer science and the three different grades. Now, this would be composition or containment. Why? Well, there's no point having grades to be accessed outside of course. The grade, if a course didn't exist, the grade doesn't exist. So therefore, the relationship we've got is if we delete grade, so if we delete course even, we can't access grade. It doesn't make sense from the scenario situation. We can still access student, we can still access the student grades by going student 1, which is Alice, 87, computer science, but we're basically saying by this setup that grades should not exist outside of course. It has no reference. So that is why we wouldn't do something like this. Self.grade and then equals, and then have a list of different, that'll be computer science, that'll be math. Because we're basically saying in this scenario, we can access the grades without even talking about the course itself. But that's stupid, that's pointless. We don't know which courses we're referring to and what happens if they weren't part of any course. So we're saying in this scenario that for students to have a grade, they must be part of a course. And we can access the information only through going through grade, which will tell us which student achieved what. So that's our relationship there. Or by going to the course itself and seeing what grades everyone got. So scenario 1, we can access students externally, we can access course externally. You can have students without being a part of a course. You can have a course without having any students. They can be accessed independently. In this, we can still access a student, but if you want to get their grade information, we have to go through class grade. Class grade needs to be a part of a course. If we got rid of course, we can't access grades. These grades will be irrelevant. They'll be meaningless. They're not a part of a course in the first place. Let me give you a different scenario. So we've got book, we've got library. Can a book exist without a library? Yes. Can a library exist without a specific book? Yes. So we're using, at the moment, aggregation. That's the relationship. One can exist without the other, but we can combine the two. We're saying here that the library, central library, can have 3 books. These 3 books are these. We can access these books independently, or we can access it through the library. That is aggregation. Okay, we've now added borrowing, its own class. So let's imagine that we want to keep a list of who's borrowed what. Well, so we've got the book, we've got the borrower, and the due date. We could do this. Self.borrower equals name. So this will be like name a person. Sod off with your name everything. Let's just do nam for name. Come on. Name space. Fine. And let's do due date. Self.due date equals date. Now, the issue with this is, beforehand we're saying a book can exist outside the library, or it can exist in the library. Now we're saying the book has to exist in the library because we're talking about borrowing as well. That changes the relationship. So actually, we still want book to be independent of the library. We still want library to be independent of book. However, what we're now saying is, in order for us to borrow, we can access book 1, who borrowed it, and the due date, independently outside, but if we were to delete library, borrowing would be useless. It's pointless. There's no point having borrowing. Without a library, we've not got a place to borrow from. So borrowing relies on library. If we were to delete book, again, borrowing is pointless. There's no point having borrowing if library or book was deleted. If we were to delete, so let's go back to the original example where we just had these two, class book and class library. If we were to delete library, we can still have a book could still exist. If we were to delete a book, libraries can still exist. But once we've got borrowing involved, borrowing will be useless without a library, borrowing will be useless without a book. Let me give you another example. What are we using here? Aggregation or containment? Obviously, we're using aggregation. We are saying that in this relationship, you could access employee or this information without the need of having a company. An employee can exist without a company. A person can exist. A company can exist without employee. That is the current relationship aggregation. They can exist independently of each other. Whilst we're using them together, they can exist without each other. That is what we are currently saying. Employee can exist without company. There we go. That's proving it. So let's imagine that we want to keep track of each employee, which department they work in. Sales, do they want to work in marketing? Who knows? Let me just sort out the indents. Okay, so what we're saying now is something slightly different. Again, we've got employees, they can be accessed individually. But we're saying that our departments are made up of different employees, fine. Our departments, so our company is made up of several departments. If we were now, based on this current structure, to get rid of our company, say goodbye. Departments would not, well, we wouldn't have departments. Departments wouldn't exist without a company. Simple as that. Our department is made up of the department name and the employees. The company is made up of the company name and the different departments. If we were to get rid of the departments, the company wouldn't exist either. We can still access employee independently, but these two are relying on each other. The very fact that they're relying on each other means that we're using composition. We can access the employee information through departments, but what we're basically arguing here is that without a department, a company won't exist in the first place. They can't be accessed independently of each other. So if we were to do this, self dot department name, okay, and we didn't use this, what we would be saying is employee, even if they weren't working for his company, would need to be still a part of a department. They have to be. That doesn't make sense in this scenario, which is why we created another class called department. So let's have a look at the original code of aggregation versus this with composition. I've just deleted department. Let's just get rid of this. So this is the original company class. This is the one now using composition. Notice how this is taking in departments, not employees. Notice how the original took in the employee as well. Why? Because we access the employee information through the specific departments. Let's have a look at another example. Okay, this is a nice simple university one where we've got professor. Professor can exist without university. University can exist without professor. We can access the professor information quite easily. Boom. Here, independently. I want you to add to the code so that we can keep track of each subject a professor teaches. Well, actually, they teach courses. So each course a professor teaches. How would we change this code? What would we add to it? What would we change around? Pause the video, give it a go. Well, the first thing we would do is we would create a class called course, where it's got a course name and the professors who are teaching the different courses. That's the first thing that we would do. Which then changes the relationship because we want the university to offer different courses. We can't have a course without the university. So self.courses equals courses. We can access who teaches the courses through course itself. We can then create 3 different professors. We then create 2 different courses of different professors teaching different courses. We then create the relationship of composition by saying that each university must have a university name and must have these courses. These courses can't exist without the university. Again, we could have said each professor teaches courses and have it as a list. But then we're basically saying that these professors must teach a course. But there could be situations where a professor could exist without having to teach any courses. So it's independent. This is independent. These rely on each other. This is your composition. Okay, so let's get into the nitty-gritty of the difference between aggregation and composition again. We're using node, these attributes, to create instances and put it into stack. Node can exist without stack. It's got its own attributes, it can exist independently, I can access them individually. So this exists separately of this. A node can exist without being in the stack. The stack can build its a series of nodes itself. But how do we turn this then into composition or containment? Well, if we were to create a new method and added it into this, what we've now created is composition in itself, because what would happen is the following. This would delete the stack. By deleting the stack, the node cannot exist. The objects for node will also get deleted. We can't access these because they will also be deleted if we were to run this code here. Without this, we could access this, each object we create independently, or we can do it through the stack. It makes no difference. But the moment we use a delete and we're deleting a whole stack, all the nodes we built in the stack will also be deleted. That would be composition, that would be containment. So by default, we've created aggregation. But if we wanted to turn this into composition or containment, we would have to delete the stack. By deleting the stack, it would delete all these objects as well. So in this example again, if we were to destroy company, it would also destroy the departments of which we've created, as in department 1, department 2. It can't exist without each other. Same with the reliance on employee. If we destroy department, it would also destroy our instances of employee 1, employee 2, and employee 3, the life cycle of it being used. Let's have a look at another example. I'd say that this scenario I'm going to give you right now is a really good difference between aggregation and composition. So what we have is a quiz. This quiz is using aggregation. Why? Because the questions have been made separately. These are our questions. And then we're passing them into quiz. Nice and simple. So they're two separate things. We can have these questions, they still exist without being a part of the quiz. Look how this is different. We've created two questions here, but they're not actually objects. If we look at before, let's do a before and after. So beforehand, we've created our questions. These are objects of question even. We're then passing it into quiz, so we can use it. If we delete the quiz, these questions will still exist. Whereas in this scenario, what we're doing is, again, we are creating these two questions, but we are adding the questions to the quiz, so question 1 and question 2. Therefore, we could argue that the quiz class is actually creating these questions themselves. So if we destroy quiz, the questions go. As we've got a structure here, a list called questions, and we're adding each question to here. So these are being used for this quiz. It's temporarily, for this quiz, going to be having these questions. If we were to delete the quiz, the questions from here would be deleted. These will exist independently, but we can't do anything with them. Whereas in aggregation, we're passing in the questions here as a list in itself. They're being used. If we were to delete the quiz, these questions would exist. But look at the data structure for this. We're generating our own list here. We're adding the questions to this list. If this list gets destroyed for this quiz, these questions are irrelevant. So in aggregation, we can basically say that our quiz is temporarily borrowing these questions and using them for its own purpose. Whereas in composition, we could argue that actually this quiz is creating these questions, generating it, and adding them into its own structure. So it owns the life cycle of these questions. And to round this up, for our exam board, it only focuses on aggregation as a form of containment and not composition. So aggregation is a form of containment in itself, but it's a weaker version than composition. The relationship is weaker. So if we do get an exam question, it's normally going to be aggregation. It's always going to be aggregation if it's done in this sort of format, or so it's basically if we're using, let's just undo this, an object. So yeah, if we're building a class, or an object, sorry, based on a class, if we're ever doing that for example, it's going to be aggregation, not containment. So if you think back to the stack, let's just load up the stack. Stack. And the examiner ever asked you what's being used? Well, we know that this is using aggregation. Well, it's containment, but it's aggregation. That's a form of containment. It's a weaker version of containment. If it was to have, remember the delete, blah, 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 that would be composition, but for exam, we don't need to know about composition. You might say to me, what's the point of this whole video? It's just so that you're absolutely comfortable in knowing there's a difference between aggregation and composition, being able to spot the two. They're very, very, very similar.